So one of the other things that came out of our workshop session today with Dr. Marsh was that we need to consider the delta G equations a little bit differently and the notation a little bit differently because we are working in the context of biochemistry. So what I mean by that, we have delta G. We all know what delta G is. And so if delta G is written just like this, just the way it is, this refers to so this is any temperature, so any temperature, any pressure, pressure, and any pH, and any initial concentrations. So when you see delta of products and reactants, but when you see delta G just like this, it's just referring to delta G anywhere, on Earth, on the moon, non-standard conditions, close to standard conditions, whatever. The other delta G's get a bit more specific. So if we have delta G naught, this refers to specifically STP conditions, so standard temperature and pressure, being 25 degrees centigrade, Celsius, and 1 atmosphere of pressure. If we see delta G prime, now what I said in the video last time was correct. It generally, in general chemistry, means you start with 1 molar concentrations of reactants and products. But in biochemistry specifically, we're referring to having the reaction vessel at a pH of 7. And so, as you would expect, if we have delta G not prime, that implies STP and pH of 7. Besides that, make sure you understand that. But besides that, make sure that you carry the not or the prime or the not prime through the equations you use. So if you're using delta G equals delta H minus T delta S, then you have to specify, if you have delta G not prime, you would put delta G not prime equals delta H not prime minus T times delta S not prime. So you carry through. The exception is with K. So if you have K refers to, so KEQ refers to standard conditions. If you're in non-standard conditions, talking about the equilibrium ratio of products and reactants, then you're talking about Q, so non-STP. So Q and KEQ are the same thing, but K assumes standard temperature pressure, so you wouldn't have to put, you wouldn't have to carry through your delta G naught, so on and so forth. You just put KEQ there. But you might want to add K prime if you're also talking about pH of 7. Besides that, we went through the general equations, which I've gone over in a previous video, those being delta G or delta G naught or delta G naught prime equals delta H minus T delta S. Delta G, so this is the thermodynamic. And then we have another one relating delta G to kinetics, so relating it to KEQ, where delta G is equal to negative RT ln K. But K would be here if this was delta G standard. If it's not standard, then delta G in general would be equal to, sorry. So this is standard. This could be standard or non-standard. Now, if we're trying to find delta G itself not standard, then we use a different equation, which is delta G equals delta G standard plus RT ln Q. And this was some real gold that we managed to get from Dr. Marsh, is that This refers to delta G varying based on non-standard conditions. So you start with a standard condition here, and it changes according to this part of the formula, which means that we're using Q because Q is changing as we change temperature or we change pressure or whatever variable we're changing in our reaction conditions. Finally, there is a rearrangement where we take, where we solve this equation for K, and that would be, so we would rearrange it first to give negative R, we'd arrange it first to say ln K is equal to delta G naught, so negative delta G naught over RT. And then we would take the anti-natural log, and K will be equal to E to the negative delta G standard over RT. And this is how you would solve for K given delta G standard and, of course, your constants here. And if you were using the log-based equation, then the log-based 10 equation, then you would just rearrange appropriately. That's just basic algebra, so I don't expect that part to be too much trouble. But I did want to make these corrections. Make sure you look at these for question 4 and my previous video updating the information I gave over question 3. And once again, many thanks to Dr. Marsh for coming to the workshop and setting us straight on a couple of these concepts. Hopefully that helps with the problem set, and good luck.